Welcome to the SEAMS studio, ladies and gentlemen. And today I'm going to talk a little bit about, well, something that I don't think that we take enough care about. Konrad Snyman has got a very good input as well. I'm going to talk about air vehicle, and here you've got air vehicle care. And you'll say to me, oh my goodness, air vehicle care, I mean, what is it that you really want to talk about? Well, the thing is that we need to keep our aircraft in a good condition. And, you know, but there are certain rules in this. So we're going to talk a little bit about the maintenance effects, the things that we need to do. One of the main things that I need us to focus on as well is, you know, who do we allow to work on our aircraft? Are we GPs? Are we getting out there? How do we judge our lives? And then, as I said, I brought Konrad Snyman with, and he's going to take it a little bit further, and he's going to talk about the pirate parts. So without too much further ado, let's get to Konrad, and then we'll talk about the pirate parts.
Filthy pirate.
Thanks, Charlie. Well, today we're going to have a chat about, as you've seen from the intro, we're going to have a look at non-conforming parts that entered the system, pirate parts. Now, aviation is a monster, and it runs on a diet of two things. The one is commitment, and the second one is money. And it does not respond well if you take shortcuts in any one of those two. Sadly, I've become more and more involved in investigations for the authority, the CAA, as well as from some of the original equipment manufacturers, the OEMs, as well as the insurance companies, with regard to parts that has been fitted to aircraft illegally, non-conforming parts. And this should be a red light to the industry as a whole, and red light to owners and operators of aircraft and on all levels. I've seen this not only in the light sport environment, I've seen it in the commercial side, and not even the military is immune to these kind of things. There are a number of ways of getting these non-conforming parts into the aviation system, getting these pirates onto your ship. The one obvious one is cost, by giving you a low price. That's usually very attractive to the owner or the operator or even the AMO, getting these parts fitted onto your aircraft. The other one sometimes is not necessarily from a manufacturer as such, but it may even enter the system via aircraft that has been discontinued or has been scrapped due to age, or even worse, aircraft that has been in an accident, that these parts tend to find their route back into the system. Any of those parts needs to, before they can be offered as a conforming part, they need to be exposed to rigorous testing and certification by the manufacturer, which is again pretty costly, and that's where the wheels come off. But let's have a look. I've got some samples here, and I'll show you some of the parts that I've been involved with. So let's go have a look.
En dan hit de
Ja, gaat het flare maken? Ja, let op. Uitveren.
Now the first example I have is from a Sycamore gyrocopter accident, where the main rotor attachment brackets failed, leaving the main rotor head to starting separating from the main rotor mast, and this led to this forced landing. Luckily everyone walked away from it. The plate on the left hand side failed in flight and it resulted in an accident. Now if you look at just closely on the plate on the left hand side from the accident aircraft, you can clearly see where the attachment bolts were torn out of position. The one in the bottom, the part that I've cut out for the lab analysis, that one failed first and the rest failed progressively as they went along. Now the plate on the right hand side is the original one. This is from another aircraft. It's a spare part, and you can clearly see even after some time that it has been in operation, the damages to those attachment bolt holes are not even comparable. One of the aspects that came to the fore during the investigation was the surface condition of these plates. Now the first one I'm showing you here is the original one. You can see the surface is relatively smooth of the plate. Now if I move over to the accident one, you can clearly see that there's a lot of what look like pits, look like corrosion pits, but it is in fact porosity. There's porosity inside the metal, and that's part of it that you will see on the actual surface. Now from this picture you can see how the main rotor head assembly started to separate in flight from the main rotor horizontal mast due to the failure of the bracket. Considering the loads on these brackets during flight, it makes perfect sense the way that the attachment ball started to tear out of those brackets, as you can see. Now the microscope investigation clearly revealed a ductile failure with a shear component, but of more concern is the amount of porosity and foreign inclusions that I've noted during the microscope investigation. Now all of these are indications of a low quality alloy that was manufactured incorrectly. Although the compositions, the chemical compositions compare favorably between the conforming and non-conforming part, don't be fooled by that. The manufacturing process was totally incorrect. But also support that notion is the hardness values between the plate that was from the accident aircraft, the non-conforming one, as well as the reference one. And just by looking at the results, you can clearly see that it's less than half the strength. As you can relate hardness to strength, these plates were not even close to conforming to the original manufacturer's specifications. The next sample I have are two attachment brackets of the main wings for a Cessna 210. Now if you look at these two components, they seem to be pretty much the same. The one on the right hand side, there has been some machining done. In fact it looks pretty rough if you look at it closely, relative to the one on the left. It seems to be much smoother and seemingly to be the original part. Well, it is not. The right hand side one is the correct part. This is the original OEM manufactured part. The one on the left though is a pirate part. Hair-raisingly so. These kind of brackets found their way into the system. Luckily for the owner, or the operator, and the pilot, the technician who tried to fit this left-hand bracket onto the aircraft noted that the bolt won't fit. He tried a number of times, but realizing that the bolt won't fit into the hole, he gave this bracket a closer look. I've marked these two parts A and B, A being the original part from the OEM, and B being the non-conforming one during this investigation. Now the chemical analysis, the spectrometric results, as well as the X-ray EDS results from the electron microscope showed that the alloys in composition are pretty close to each other. Now the chemical composition, as you have seen from our previous example from the Sycamore main rotor mast plates, that the chemical composition isn't necessarily the final say whether they conform or not. So I opted for a metallographic investigation to determine the rolling direction orientation of the grain structure of the alloy. Now, why is this so important? Firstly, it will give you a clear directional strength inside your component. And considering that these are main wing brackets for an aircraft, those orientations are of utmost importance. Now, if you look at this colorful picture, you can see the clear directional orientation of these grains. And that's pretty much the closest metals can get to carbon fiber with regard to strength orientation. Now, I've used these orientations and different positions inside those two brackets and took some samples out of it, and I marked those samples clearly and compare those two positions between the brackets A and brackets B. By applying the metallurgist's bag of tricks, I mounted and polished those samples and etched it with a mixture of acids to see the grain, to compare those grain structures. Now the results are pretty disconcerting, and you can clearly see between bracket A and B at two different positions as well, that there's a clear orientation of bracket A with regard to the forge direction that forces your grain structure in a certain direction. Therefore, the directional strength can be attained. Now, bracket B, you can clearly see, are not even close. Exactly the same positions. It shows that that there's only a singular directional orientation of the grain structure in part B, which is the non-conforming part. Now, from these results, you can derive that these brackets have a different history. Bracket A, which is the conforming one from the OEM, are forged as it should be and then machined to the exact dimensions. Bracket B, on the other hand, the one that slipped into the system, were just machined from a rolled plate, leaving it without that directional strength that you require for a component in this application. The investigation also revealed some variations in hardness and obviously then strength at those different positions, as well as variations in dimensions. Thanks, Charlie. I think that's all we have time for on this rather touchy subject, and it's a very, very serious one as well. There's a few lessons, obviously. The first one will be, do not take shortcuts. Aviation is expensive. There is obviously no cheap way to beat gravity at will. If the price is too good for a part that is offered to you as an original, then it most probably isn't. And do not take a shortcut at all. Stick to the OEM supplied parts. The reason why they are so expensive is that they are exposed to rigorous testing to be allowed to be certified to be used on your aircraft. So stick to the OEM parts. If you have a home build or a light sport aircraft and parts are not available anymore and you have clearance to reproduce a part, follow clear engineering principles. Get certified and qualified and reputable engineers to do that backtrack engineering for you before you reproduce a part. That is of utmost importance. And obviously the last one, I tend to throw this in many times, as I did before, is that excellent and well done and well planned and well executed pre-flight inspection can honestly save your life. Thanks, Charlie.
Well, there we have it from our own crash lab. Kunrad, thank you very much. Now, you'd probably ask, but why have I gone to the point where I wanted to first show the video before I'm actually getting into this air vehicle care? Well, there's a couple of things that he mentioned. You know, he mentioned about that flying is not cheap, and he said that if the parts are not right, that they're very specifically made, and that is why many a time you will get, and you will say, but I can get this washer in a DIY store. Yes, you can. It will have the same dimensions, but it's not in any way going to be of the same quality and of the same material. Does it make a difference? Well, you've now seen that it does make a difference. So the point is, well, let's get over to and see. Let me just get that one there. Let's carry on with the air vehicle care. Right. Starting off here, I just want us to talk a little bit about decision making. And the first one I've got there is the freedom of choice. And you're going to say to me, but you know, in other words, everything I now say that it's not freedom, it's contradictory. Freedom of choice. The choice itself doesn't give you a choice. All right, let's have a look at that. Freedom of choice. I said not freedom of interpretation. Yeah, but the law and, yeah, we can bend anything, you know, to the point that we actually like it. But as Kunrad have just shown us, you know, if the striations and the linearity of the materials and stuff and all the fancy stuff that he was doing, if the manufacturing process is not right, it is not right. It cannot bear the stresses. You might think so. Man, I've seen aircraft that has had 100 different weldings and different brackets on, for instance, the alternator housing on the engine. But because it's not the right stuff, it cannot withstand the vibrations and, you know, the hard work that a machine that is built for aerial application. It is not the same. All right. It's not freedom in deciding on the rules of the game. Nobody has asked you, you know, what do you think? Is the lift formula, is the conditions for corrosion? Do you agree with that? Nobody has asked you. Remember the thing about maintenance and the environment that we work in, it's a scientific environment. You and I can only work with the results. Oh, and what about when the machine is designed? Well, the machine was not necessarily designed for your weight. It wasn't designed necessarily for your size. It was designed for very specific limitations. Now, whether you liked it or not, that is what you get. If you buy the machine, you're stuck with everything pertaining to that machine. Choice cannot change the universal and governmental rule applications. And okay, I could have said the civil aviation rules and regulations. Remember, those are things that we've got absolutely no say in. Choices are not negotiated. Ooh, okay. When a situation arises, we can't say, all right, I don't like those choices, you know, they're not good for me. But if you give me these choices, if you give me a choice between R1 million and R1 million and 50 rand, R1 million and 50 rand, you know, then but you don't make the choice, you don't get to choose the choices that you work with. The choices are the things that will present itself right at that moment in time. Many times we've got decisions, but the decisions need to lead into or before we have to make the choice, and we'll get to that. Choices are fact and realities presenting itself in a certain scenario, and there is no freedom of choosing the choices. I like that. There is no freedom to choose from the choices or to choose the choices. The choices are presented to us, and then we work from there a little bit further. All right, the accident that I want to talk about today is, and remember, really, whoa, let's just get this thing straight again. It is nothing personal with whoever was involved in working with or in and on and so on. The accident is there for us to learn from, and if we cannot learn from it, then it means that we're going to all have to die repeatedly where we could have learned from something else. Yeah, and that's where I get a little bit of a problem, because people don't really want to learn from. But now please pay attention, because, you know, this could have been probably any one of us. I said there, well, the synopsis is from the CAA, and it says there on May 12, 2016, approximately that time, accompanied by a passenger, they started the takeoff roll from runway 01 at Kitty Hawk. During the takeoff, they experienced loss in engine power. Very critical. That's the first point. I'm just going to put it in red there. It then turned. Now, the aircraft then turned to the right, and followed by a 270-degree turn to the left. So first it turned, and then it turned again to the other side, 270 degrees. I'll give you a picture of that just now, what is meant by that. The pilot was fatally injured, and the passenger suffered minor injuries. Whew. You know, this is the thing, is that I want to just use that point quickly while I'm thinking of it. In this same accident, with basically the same dynamics, the one person died, and the other one, minor injuries. Come on. If you can explain that one, we probably can take a couple of more chances. But because we cannot explain it, you might be lucky, and you may not be lucky. All right. The aircraft was destroyed. Investigation revealed, listen to this now, and I want to make sure that we've got this. Revealed the pilot attempted an successful forced landing due to partial engine loss. Okay, there we've got the partial engine. Now, the partial engine power loss was due to the result of the number 3-cylinder tappet adjuster of the inlet valve was found out at the bottom of the rocket chamber. In other words, the screw that turns in and out to set the gap was never locked, and then it vibrated out, fell out, and it actually did. Now that piston becomes basically non-usable, and if you lose one piston, then the power is not good enough. All right, the Luft tappet adjuster renders the valve operation inoperative, which caused the cylinder not to function as resulted, and the engine power providing only 3 cylinders. And as I said, 3 cylinders is definitely not good. Now, the CAA had a couple of contributing factors there. They said partial engine power loss due to the loose tappet adjuster. All right, so the very first one that we've got here is from a mechanical point of view. Did the engine just back up on them? Somebody was setting the tappet, and they didn't lock the tappet nut. That's all, or the tappet screws. All right, let's have a look here. Now, this is where the pilot comes in. Overweight condition. The aircraft was overweight. Sure. Now, that sucks, because here you've got less performance out of the machine, and you're sitting with an overweight, and by the way, it was rear loaded as well, a little bit too much, and the center of gravity actually moved rearwards. Was it a major contributor? Well, not really, but it did contribute. The overweight definitely gave them less of a fudge factor. The pilot didn't make the engine perform less, but the pilot didn't give himself the best chance should something like that happen, because we trust everybody else, and we trust that we don't really have to stick to the known set procedures. Probably, I don't know, But what are the choices that were applicable? Now let's look at the pre-sortie. In here I'm talking to the pilots now. There's only a couple of things very quickly. Do you know your aircraft? That'll be the first question. And then obviously from a pilot maintenances, when I know, I must apply. If I know the max all-up weight, I mustn't exceed it. If I know the center of gravity, I mustn't exceed it. If I don't know what the max all-up weight of the aircraft is, then I mean, really, this is not how we taught. We get all relaxed about it, but that's not how we taught. So think about that and think about it clearly, because, yeah, your procedural knowledge and your emergency procedures. And there I use the word recency. Now you'll see that the dictionary doesn't necessarily like this word recency, but it means how recent are you and how recent have you got the information up in your head. Because remember, here we're taking off, we're all actually pretty relaxed, the engine that's not performing so well, and then all of a sudden everything goes pear-shaped. And at that moment in time, if the stuff is not up here where we can quickly get access to it, there's simply not going to be enough time to do what we have to do. All right, now we get to the machine maintenance here. The machine maintenance. A proper qualified AME, AP to work on the machine. Aircraft mechanical engineer. All right. Aircraft mechanic. Easy. But the second one, and let me just get to this one, is the AP, the approved person. Now that is by RASA. That's the recreational body that is looking after that. They appoint approved people. Now, what we found in this specific accident is that, yeah, the AP worked on it, but then at times it wasn't the AP, somebody else. We don't know who, but they worked on it. Oh, that is, I don't know. That is really, really looking for trouble. Proper administration of the maintenance wasn't done. Proper administration of the parts, not done. Acquisition of properly certified parts, don't know. Proper defect logs wasn't kept, and and the follow-up, neither. What choices were applicable? Which choices did we have prior to the accident? These are the choices. You've got a choice on how you look after yourself, how recent you are, how competent you are, how well you know your machine, how well you understand the aerodynamics involved. You really, really have a choice. If, you know what is that old saying? If all else fails, then we will read the instructions. Just a reminder, if it all else failed, it means there will be no need for you to read the instructions in an aircraft. It's quite, well, straightforward. Okay, but I need you to show the machine in the maintenance. Are those choices that we have? Yes. Who works on my aircraft? That's a choice. How well they keep up with the book. And don't tell me, yeah, but you know, I didn't know that we must, you know, note everything down and the bookwork was so important. Well, you better start learning fast. Because the problem with this is that, all right, now we're gone. And the insurance, and the passengers, are they perhaps going to sue? Because clearly, if I knew about everything that I transgressed, there's going to be certain repercussions. It's not going to be your problem if you're under the ground, but it's still going to be your people's problem. So, I don't know. While we're alive, it actually makes sense that, you know, don't put everybody else in that negative vibe or negative side of things. In glory, The reason that I say this in glory is if I look at the picture and I look at the aircraft, I mean, come on, that is beauty. An aircraft, look at the lines. Ladies, I don't know what you're going to call it. You'll probably also call it sexy. I don't know. But it's super cool. Yeah, but Charlie, I don't like that particular aircraft. Oh, really, come on, man. I'm talking about, and as an aircraft enthusiast, as long as it's got wings, I mean, come on. It's a piece of beauty. But it's in glory. It's standing there. It's ready to do something for us. But there are rules to this game. No, I'm not trying to get everybody scared out there. Please. What went wrong? AP and non-AP working on the machine. I'll get to this here. The poor workmanship by technicians, and it's not myself that's saying that. This is in the CAA report. They say poor workmanship, low quality work. Really? Sure. I don't know. I've got a very old bucky. So if you don't know what a bucky is, it's a little truck, okay? And it's old. I don't mind if the backyard mechanic works on that or if somebody practices on that. I really don't mind, okay? Because it's old and you know, in fact, what can go wrong? It's not going to be a big loss or anything, and not too big deal. Hey, but my car, my new Toyota Corolla, my new Mercedes-Benz, am I going to let anybody work on that? Whoa. You don't let even anybody work on your brand new tractor that you bought. Yeah. But you let anybody work on your aircraft. Doesn't make sense. Don't know. Why is it that we become penny wise and pound foolish? The tappet adjuster screwed out. Okay, we've got that. No, I've got to put this in red. No paperwork done by the technicians. Listen to this one. Listen to this one. It says mandatory, compulsory, and recommended service bulletins, service letters were not incorporated during the maintenance actions. Hey, who was looking after the aircraft? Nobody. But those compulsory stuff is just for the manufacturer to make money. Well, it's so sad if you believe that. You know, when they manufacture something and they see that there's repeatedly that something goes wrong, blah, 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 then they say out, this is a compulsory. You've got to fix this. Because we don't want you to have the same pain as the guy before. Yes, it could be a matter, well, it's compulsory. It means it's serious, you know, problems if you don't do that. I don't know how to get it into some people's head that, really guys and girls, okay, let me get a little bit less. Yeah, engine change documents, not the aircraft. Now listen to this. The aircraft in the accident, the engine that it had in was not the engine that it's supposed to have in. They had engine A in and they put engine B in, and at that time the CFA was issued, and then they put engine A in again, and then the aircraft had an accident, and nobody could give any recollection. What is happening to the machine? What was done to the machine? Why was it taken out? It's no record of aircraft defects listed. No, we don't want to write the defects in. No, because then we have to fix it and we have to give a record of that. I know it's a pain in the butt. And I can say many things. But I think it's a point that we get to in life where we would say that, you know what, if I continually write up the defects, or as we call it, snags, I can ensure that my aircraft is fixed and it stays in absolute tip-top condition. Or I do not write it up and we forget and we don't know what we're doing and we forget, and eventually we pay the ultimate price. It's been proven over and over again. You don't have to die to learn from somebody else's death. All right, here's the flight path. I just want to get that pen here. That was since after that, this is where the takeoff started. Okay, so he rolled, took off, a little bit of rough running engine, poor performance. Poor performance was already, I think when the aircraft went through 30 or 40 knots, there was already poor performance becoming visible. So the takeoff itself, as it progressed, the engine actually became worse. And there you can see, and then obviously that ended up where the accident happened, and that was the fatal part. That brings then the question, all right, whoa, whose fault is this? Well, the pilot wouldn't have had to dig deep here if the engine didn't fail. The overweight and rear CFG of the aircraft had nothing to do with the partial engine failure, and that became obviously worse as you demanded more from the aircraft. So eventually, the little bit of fudge factor that they had in the weight was gone, and the control surfaces, the controls obviously not as effective as it should have been. All right. I understand that we want to see what caused the accident. As a pilot, I want to look all of you in the eye and say the following. You know that when we fly and anything goes wrong, there's an engine failure or partial engine failure. And by the way, those are the very dangerous ones because, it's like a little bit of a guessing game in the beginning. So I feel very sorry, obviously, for the people that's involved in this. The thing is that as pilots, we are dealt the cards. It is not our choice whether the engine is going to fail and where the engine is going to fail, or that we're going to have a problem or where it's going to happen. In fact, it shouldn't happen, and it probably won't happen, and unless something goes wrong, and it can go wrong. All right? And then we will have a choice between how we're handling the adverse condition. Not time now to worry about who's to blame. Hey, what must I do now? We can fight about it later on. But now, I must first be able to get this baby on the ground. And now, if I'm not recent enough, now if I didn't have a plan for after takeoff, now if I didn't have a plan B, there's not going to be time to make one. Think about that. Right. Okay, aircraft loading and resultant. Now, I just call that negative enhancers of the situation. That's the overweight in the aft CHG, and I said this is where the fudge factor was lost. Now, remember, once the engine started packing up, now the poor performing engine mustn't just do with the normal max all-up weight, it is now got to do with an overweight condition as well. The aft CFG means that the control inputs are different, which creates more drag, which creates more power requirement, blah, blah, blah. And so we go on. It's just a vicious circle. Somebody asked me, is it possible to walk away? Yeah, well, I think it was possible away. It seems to be that there was enough space to do what we had to do. But then, why did he turn around? Why did he try and go back and then not back to the airfield but 270 degrees? It's as we go through, if we have a plan before, at least it gives us just that little bit of an edge to make a decision. So I'm going to take off on this runway, and after this, if I get anything wrong there, I'm going to go there because there's an obstruction or there's an open field or there's there. Be very pertinent to the environment in which you are working there. It is not a little rhyme to say, okay, and after takeoff, I'm going to do this. Because you're going to do this, it doesn't matter whether you're in Cape Town or in Queenstown. All right? It doesn't matter. But there's one hell of a difference between Cape Town and Queenstown when it comes to the overshoot area and the options available to the pilot after takeoff. I don't know where these two places come from, but anyway. Okay. Now, the poor performance afterwards, or let's say the degraded performance, obviously comes from there. Now, in the first one I said that it was in glory, and here I said it's in tragedy. It's in tragedy. The thing of beauty is now destroyed. Now, we say that decisions must be made. Okay, here I'm just confused with the knobs. Must I go here or there? But let's go back there. Here we say, according to the best, no. Decisions must be made according to the best standards and best practice. Do you know the best standards? Do you know the best practice? You know what? You do. But it's still your choice whether you are actually going to follow best practice or are you going to follow the perceived easier practice. Oh yeah, you're going to go for cheap. I suppose if you find your life to be cheap, then, you know, cheap it. Look, at the flying school, obviously, we can't go cheap. We must do it right, because our winged results, they live. They must fly. They must work. Can't afford to have a cheapie. Poor quality parts leads to poor life expectancy. That is exactly what Kunrad said. He said, man, don't think because it's cheap that you've struck a bargain. You just made an accord with the devil because you're going down. Sure, okay. Maybe that was too preachy. All right, let's get back here. Poor and cheap workmanship leads to cheap life expectancy. Weight and balance is factual and heeds no opinion. What do I mean by that? Nobody's asking you about the opinion of about how much weight. The fact that you got away with it in the past is you are lucky. And if there's a slight engine deterioration, you're not going to be lucky anymore. You've taken your own fudge factor and just threw it out of the window. How do you count that in dollars? Wait, it doesn't just go about that. We need to follow the procedure, because how do you follow that? The procedure is there to guide us. But if it seems easier not to do that, hey, when we do aerobatic training, the people think, ooh, yeah, no, I can do the loop and a roll today. Show the guy, hey, yeah, stall turn, flick out into the spin. There we go. How do you recover? Well, I was there. I know how to recover. And I don't care getting into these unusual attitudes because I've done it. I was trained to do that. But I stick to the rules. Oh, the only way I can stick to the rules is to actually know the rules. It's sort of like a prerequisite there. Make a decision for alternate actions prior to commit any stage of flight. That's an important one. I'm going to go in for landing. What are my options if this is not going to work? I'm going to go for takeoff. What are my options if this is not going to work? And make the decision. I'm going to go there, I'm going to do that, I'm going to do here. Walk and talk, feel, and go through the process, and you will be properly prepared. Then, everything will jump up into your short-term memory, and it'll afford you more time to handle the actual emergency. I'm not pretending to say that, you know, that cannot happen to me or anything. Of course I know it can happen. I just want to give myself the best possible chance. And for that matter, obviously, my passenger as well. So decide to follow the rules. You know, when the negatives, I want to write it here, when the negatives outweighed the positives. What are the positives? What is it that we can do? No, I don't. I want young people to come and enjoy the environment. But they need to understand there are rules and regulations. And sometimes we got to weigh up. But are those choices, if we really got a choice, what we pay attention to? And I said the airworthiness of your machine is the first thing. Know the history, have your snags, no, sorry, not your snags, the aircraft snags. Have them fixed. Do the paperwork. Pay attention. Be interested. It is not your 1960 Ford on the farm that you are using for bundu bashing. This is not the 1976 Massey Ferguson tractor. It's not. It might not cost as much as your brand new fancy car, but it sure as hell can lead to much more problems, or many more problems, than the car can. All right, never mind that. Proper pre-flight, and here I'm talking about the pre-flight, the flight planning session. Weight and balance, weather, density, altitude, all the stuff. Performance-wise, what is it that we have? We do proper planning. Yeah, but we can't, you know, we've got to overtake, you know, I can take 3 people and I can take the fuel, but I'm going to be so much overweight. Oh well. If absolutely nothing goes wrong, then you'll probably get away with that little bit of overweight. If anything slightly goes wrong, then you might not get away with it. And this has got nothing to do with money. This is because we've got a tool that can do that much. We need that much, and we try and force this little tool into doing this kind of work. Well, unfortunately, there are penalties, and the penalties, you know, must be paid from time to time. A proper pre-flight on the day, the machine engine check, the run-up checks. Okay. Now, go and no-go situations during takeoff. That is a pre-decision. What am I going to do, and if not? And then the last one, the machine performance during takeoff. What do I mean here? I know, sitting on the runway, we lined up, we're ready to go. Okay, and throttle up, go, and we check. Right, we've got full power, and the temperature, pressures, and limits, and we see that the airspeed is increasing. And we go through the thing, and now it's speed and outside and speed and you must bring the engine in somewhere. It is not to say that because you whipped it open and it responded to the it's going to stay there. The engine, you have to work in some extra eye contact somewhere, and you must pay some attention to it somewhere during the takeoff. You know, there's so much split attention and not easy and stuff like that. But that's where you're given ears. Listen, this is the engine noise. That engine noise is not right. I know from takeoff runs we should have been airborne, but we're not. Why are we struggling? What is different from what I expect it to be? But listen now, if you expected something, it means that you are you're thinking about thinking, all right? You are thinking about expectations, and then you've got better probability of paying attention to the deviances from what you expected. But if you don't expect anything, then, well, there would be no need to check up for anything, because if I don't really expect something, then things can actually go pear-shaped, and I will not recognize that I actually wanted an apple shape. And now the apple is in a pear shape, and therefore it doesn't fit the frame. Okay. It's just one of those things. Conclusion? Because reality does not strike every time we transgress, we've got this false sense of our newfound realities. I mean, it's so great. And our people, I've landed a few times at night. I haven't a night rating, but I'm pretty okay. I've inadvertently gone IF a few times, and I got out of it. I'm okay. You guys that are worried about things, you are just overcomplicating the whole thing, and everybody's trying to just give us to carry on. Well, unfortunately, if this is how we teach people, then accidents like this can and probably will be on the increase. We become our own heroes in reflecting how the system is for suckers only. Okay, I had to think about that sentence for a while. What does it mean? Well, simply that, we think if we do something which we are not supposed to do, we get away with it, then we are heroes. Well, you're not. You may be a very temporary hero, and you're only a hero in your own eyes. Me? I know. Not a hero, you're an asshole. It's on TV, I shouldn't say that. We only pay respect to rules when directly scrutinized. Hey, when the CIA rocks up, or when somebody, and then we're so nervous because we're not used to doing this stuff right. And the moment that somebody's checking over our shoulder, then we're all getting nervous because we know that we're not doing stuff right and we're not used to doing stuff right, and therefore all of a sudden it's a problem. Why don't you just get to do stuff the right way and continue doing it the right way, and then there will be no nerves involved? Yeah, I still get nervous when I get checked out anyway. Money can fix many things, but it cannot fix life. You cannot buy resurrection. Maybe you didn't know that one. Yeah, but don't tell me what to do. I'm a big businessman. Yeah. I've seen many big businessmen. And you know what's the best for a big businessman? Is to have a full-time pilot and a decent aircraft and not to interfere. But if you want to play with it, then unfortunately you've got to come down to our levels, the mere mortal level. All right, to follow the rules is far greater, and then I said here, to follow the rules is cool. All right, that sounds, to follow the rules is cool. Are cool, am cool, and I believe it is cool. It is cool. Listen, young man. Listen, young lady. To be the rebel in aviation only amuses the other people that has gone astray and has gone wrong. Not the rest. Those in the know. We know. And we know when you're stupid. Stupidity is to know what is right, and against all the odds, not to follow good reasoning. That doesn't sound good. So what it's all about? Well, it's all about what we want. What is it that you want? Well, I want my baby to sleep nicely in the garage tonight, and I'm going to just have the best mechanics work on her. I'm just going to have the best parts in her. I'm going to go for quick check rides. I'm going to make sure that I stay within weight and balance limits, and I'm going to make sure that I'm going to look after this baby the way that I look after my loved ones. All right. And I think if I press that knob, it will say, that's the end of that. Until next time, have fun.